Hi everybody, I'm Professor Rad, and today we're going to solve a few word problems that involve rates. So let's just jump right on in. So the first kind of rates we're going to look at, these are really common in algebra classes, and they involve distance, rate, and time. So we have two formulas. These are really the same formula that I've kind of rearranged, but let's take a look at them and kind of talk about them. So this first one is your distance is going to be your rate times your time. So for example, if I'm traveling 30 miles per hour and I travel for 2 hours, then that means I will have traveled a total of 60 miles. So 30 miles per hour, that would be our rate. Time was 2 hours, and we traveled 60 miles during that time. You can also find a rate, or for distance, rate, time, this would be like your speed, how fast you are going, by dividing that distance that you traveled by the time. So for example, if I traveled 60 miles over the course of 2 hours, 60 divided by 2 is 30. So I would be traveling at 30 miles per hour. So these are two formulas depending on the information that you have and the information you're looking for that you can use to work with your distance and your time. So let's go ahead and work through two examples. This first one says it takes Linda 45 minutes to drive to work every day. So when I see minutes, minutes is a measurement of time. So the time is 45 minutes. If her commute is 48 miles, miles is a distance. So 48 miles. What is her rate of speed? So we're looking for what is her rate. Now, if you've been watching these videos along, you may have noticed that I've switched away from highlighters into writing out my summary here on the side. I like to do that for rate questions because very often in a rate, the item or the variable you're looking at is based off of the units that you're using. In other words, it doesn't say it takes Linda a time of 45 minutes. I have to make that inference that 45 minutes is the time. So I find it easier for me to do that kind of summary and that analysis, writing it out on the side instead of highlighting. But if you're comfortable highlighting here, feel free to continue to do that. That's totally fine. When I write this out on the side, though, I can see that I have time and distance, but I'm looking for rate. So since I'm looking for rate, I'm going to use the rate formula. So I have rate is going to be distance over time. So Linda's rate is going to be her distance, which was 48 miles, over the time of 45 minutes. And they want us to give our answer as a fraction in simplest form. So I'm going to use my calculator to help me out here. So we've got this fraction of 48 miles over 45 minutes. And there's not really a way for me to enter those labels into the calculator. So I'm just going to enter in the numbers and it'll still simplify the fraction for me. So we have 48 over 45, and that gives me 16/15. So this will be 16 miles in 15 minutes. There we go. That's going to be our answer for part A. Now let's take a look at part B. Part B says Edward travels at the same rate of speed that Linda does, but it only takes him 15 minutes to get to work. About how many miles is Edward's commute? Okay. Oh, excuse me, my goodness. So he travels at the same rate that Linda does. So rate, Linda's rate is what we found. So that's the 16 miles in 15 minutes. It only takes him 15 minutes to get to work. So minutes is a unit of time. Approximately how many miles is Edward's commute? So miles is a unit of distance. So that's what we're looking for. That's what we don't know. Okay, so since we are looking for distance, that's what we don't know, I'm going to use the formula that has distance equals. So distance is the same as rate times time. Okay, so our rate was 16 miles per 15 minutes. And the time was 15 minutes. And then we can multiply those. So 16 fifteenths times 15 is going to be 16 miles. Okay. Now, I know that it's going to be miles because I'm looking for a distance, and it asked me how many miles. I also know it's miles because that was my unit of distance in the rate that we used. And actually, I didn't really need my calculator at all, right? If I'm traveling at 16 every 15 minutes I go 16 miles, well then in 15 minutes I'm going to go 16 miles. That's what the rate is saying. So this one I didn't really have to use the formula to. I could have kind of figured out without that. But if I'm using the formula, that's what it looks like. Now, this concept of rate extends to things beyond just distance and time. So let's look at another example that involves a rate, but it doesn't involve distance. Okay, let's take a look at example 9. It says, Pete is trying to make some extra cash this summer. He knows that generally he can mow a lawn in his neighborhood in 0.75 hours. If he mows for a total of 24 hours this summer and sets its wage to be $25 per lawn, how much to the nearest cent will Pete earn by mowing lawns? Okay. So let's go ahead and think about how we might solve this one. So let's see, let's summarize our information first. So he can mow a lawn in his neighborhood in 0.75 hours. Okay, so he can do one lawn in 0.75 hours. Okay, that's a rate at which he mows the lawn. He mows for a total of 24 hours this summer. So total 24 hours. And he sets his wage to be $25 per lawn. Okay. Okay. So let's figure out first how many lawns he mows. Because if I know how many lawns he mowed this summer, then I can figure out how much money he's going to make. So I have my formulas here of distance and rate and time. But notice that instead of like miles per minute or miles per hour, I have lawns per hour. So instead of distance with this rate, I have lawns. So I could kind of think of this instead of distance being rate times time. I could think of it as my lawn is rate times time. Or in this case, the rate was number of lawns over time. So this is why I said we can kind of use that distance rate time formula as a basis for doing something different, even if it's not distance. The principle is going to remain the same. So I can figure out how many lawns he mowed by taking his rate and multiplying it by the time. So let's do that. So the lawns are going to equal the rate, 1 lawn out of 0.75 hours, times the time. So he worked for 24 hours this summer. So I'm going to do 1. Now I can't use the fraction necessarily, so I'm going to just do divided by 0.75 and then times 24. Okay, so he did 32 lawns this summer is what it looks like. Now, what are we looking for? How much to the nearest cent? Okay, so I'm looking for money answer. So we know we're going to mow 32 lawns. Oh, and here's the money. We know we get $25 per lawn. So we can do a similar kind of thing here, but now let's do our distance is rate times time. And I'm choosing this formula because I have a rate. I'm not looking for one. I'm looking for the money, and I know the number of lawns. So the amount of money Pete is going to make will be the rate at which he earns it times the number of lawns. So Pete's going to earn $25 per lawn. So the money he makes is going to be $25 per lawn times the 32 lawns. Ooh. So Pete made $800 this summer, looks like. Cool. All right, so that is one way to kind of puzzle through this problem. There are other techniques that you can use as well. So for example, if you were like, why are we bothering to like think about this formulas? Can't I just multiply? Yes, in this case, we could just multiply. But it's nice to have like a foundational explanation for why. So the reason that this multiplication works, if I think about the units that are going on, I have dollars per lawn times lawn. And if I think of it in terms of fractions, the lawns cancel out and I get my dollars back. So the units are making sense for the operations that I'm doing. So if you're ever wondering like, well, can't I just multiply or can I just divide by this? Check to see if the units work. So for example, if I wanted to know, okay, well, can't I just multiply 0.75 by 24? That 0.75 was hours per lawn, and the 24 is hours. So if I wanted to know, could I multiply this 24 and the 0.75 by checking out the units, notice that they don't cancel. The hours are both on top. So that means I can't do that technique. I couldn't just multiply 0.75 by 24. So again, if you're curious, can I do the thing? Check the units and see if we get some canceling and you get the units that you want. All right, so here are some questions for you to try out on your own. In the next video, we're going to start to apply some letters to things instead of using out these words. So I'm looking forward to seeing you in the next video. In the meantime, have an excellent day. Bye for now, everybody.